Good evening to everyone present here. I am Dhanusri of class 9 going to explain about the topic work in physics. Now let's start our topic with a small definition. First, what is work? Work is defined as the magnitude of force and displacement. So it is explained as W equal to F into S. There is another formula to express the work, which is equal to W is equal to force into displacement into cos theta. Here cos theta represents the angle made by the body with the surface which it is contact to. Now let's see which type of quantity is work done. Work done is a scalar quantity. Why it is so? Because if we are multiplying vector into vector, we will get a scalar quantity. Force is a vector quantity and displacement is also a vector quantity. So the work done will be a scalar quantity. Units of work done. Generally, there are two types of units. One is absolute and another one is gravitational unit. In absolute unit, we have two types, SI and CGS. SI unit of work is joule and CGS unit is erg. Gravitational unit. In this also we have two types of work, two types of units which are SI and CGS. In SI we have kg weight per meter and CGS gram weight per centimeter. Relation between joule and erg. 1 joule equal to 1 newton into 1 meter, which means if 1 joule of work is said to be done, then the 1 newton of force should be applied on a body and the body should displace at a distance of 1 meter. Then we can express 1 joule equal to 1 newton into 1 meter. 1 newton equal to 10 power 5 dyne and 1 meter equal to 10 power 2 centimeter. 1 joule equal to 10 power 5 dyne, which is multiplied by 10 power 2 into 10 power 2 centimeter. Therefore, we get 1 joule equal to 10 power 7 dyne centimeter. 1 dyne centimeter is equal to 1 erg. So, we can express 1 joule equal to 10 power 7 erg. Types of work. There are three types of work. Positive work, zero work and negative work. Now let's know about which type of work will be used in our daily life situation and how does it implies in our life. Positive work done. Positive work done refers to if the work done when the force and displacement are in the same direction. In this picture we can see that the girl is pulling a car in a particular direction and she is applying a force to pull that rope. And the motion of the car is also on the same direction. So here both the force and the displacement are in the same direction. So we say that positive work done is taken place. Zero work. Zero work is defined as whenever work and displacement are perpendicular to one another or even either force or displacement is zero. Let's take an example. If we are pushing a wall, we are applying a force but there is no displacement. So, as per the definition, W will be equal to F into S. Here we are applying some x newton of force and there is no displacement. So, it will result as 0. Therefore, the total work done will be 0 joules. Here, there will be no work. And if we are seeing a body in a circular motion, the force will act towards its center, which is known as the centripetal force. Same way, in this also, the work done will be 0. Negative work done. When the force applied is opposite to the direction of the motion or the displacement. Negative work done is usually taking place in our daily part of our life. If we are writing a pen, we are using some frictional force. It will act opposite to our motion. So we can say the frictional force is the best example for the negative work done. Work done against gravity. Work done by a body is against the applied force if the displacement is in a direction opposite to the force. In the case of gravity, if a body is lifted above the ground, if you are lifting above the ground, there is a force which is pulling the body in the downward direction. So that the gravitational force, we are applying the force against the gravitational force. So here the work done will be against the gravity and it is expressed as work done is equal to mgh. M refers to mass and G refers to height, G refers to gravity and H refers to height. Whenever we are taking the body in the upward direction, the height will be, we will take the height as negative, and when it is moving in the downward direction, it is usually represented as plus. Formulas. Work done can be represented with many other formulas. W equal to force into displacement. W equal to, we can write the force as the product of mass into acceleration according to the Newton's second law. So we can derive a formula as W equal to ma into s. Another formula is W equal to fs into cos theta. W equal to mgs. This will be refers to, this will imply in the situation where the work done is against the gravity. Now we can see some questions related to the work done. A force of 7 Newton acts on an object. The displacement is 8 meter in the direction of the force. Let us take it that the force acts on the object through the displacement. What is the work done in this case? Generally, the formula for work is equal to F into S. Here they have mentioned that force is acting in the 7 Newton. So we can take force is equal to 7 and the displacement is moved to 8 meter, which implies 7 into 8. 56 joules of work is done in this case. We are not representing the force as negative here because this is they did not mention that the force is acting reverse to the direction of displacement. They both are in the same direction, so we will get the work in a positive value. Calculate the work done in lifting 200 kg of water through a vertical height of 6 meters. Here the work done is against the gravity. We already saw if the work done is against the gravity, we will get the formula as mgh. Here we are lifting the body, so it is opposite to the direction of the gravitational force. So we will take as minus mgh. Here mass of the object is 200 kgs. Gravity we have to take as 10 meter per second square. And the height is 6 meters. So minus 12,000 joules of work is done in this case. A ball is connected to a rope and swung around in uniform circular motion. The tension in the rope is measured at 10 Newton and the radius of the circle is 1 meter. How much work done is in the one revolution around the circle? Here we can first visualize the image. There is a circle with 1 meter as the radius and there is a rope which is tied to the circle. So the force which we are applying is 10 Newton and we have to find the work done. Work done is represented by F into S. Here the force will act towards the center, which is known as the centripetal force, and the displacement will be perpendicular to the force. We have to take cos theta here, the formula for the work done. Here the angle between the surface and the rope will be 90 degree. Value of cos theta in 90 degree will be 0. So the final work done will be 0 Newton in this case. An object of 10 kg experiences a horizontal force which causes it to accelerate at 5 meter per second square, moving it a distance of 20 meter horizontally. How much work done is done by the force? And if you are taking the formula, work done is equal to force into displacement. Now we can write the force in the product of mass into acceleration. Here mass of the body is given as 10 kgs and the acceleration gained by it is 5 meter per second square. And the distance which it is moved through the force is 20 meters. Here 1000 joules of work is said to be done. Thank you.